Hey guys, this video is just to record the Heat and Seasons in 3 Gizmo that you guys have been working on the last 2 days. So you can use these pages to compare them with your own, or just use it as a good way to review some of the concepts from the experiments/gizmos that she worked on. All right, starting on page 9, the heat absorption gizmo went over and had you use a flashlight and a green brick. The green brick was meant to represent Earth, and the flashlight was meant to represent the impact of the sun's rays on Earth. So let's look at some of the temperatures that you guys should have come up with for the different angle degrees. For your final temperatures, you should have gotten 31.6 degrees, 28.6, and 24.6 degrees Celsius. Depending on the angle, you would have gotten a different final temperature. Based off of those final temperatures, we can figure out that the strength of the rays went from strong to medium to weak. If we were to compare, we would know that since 31.6 is the highest temperature, that would be the strongest ray. And then so on and so forth with medium and the other weak rays that would fall with the 24.6 degrees. When it comes to the special days, they would align as such. The summer solstice would be getting the most direct rays. The winter solstice would get the weakest rays, thus leaving the fall and spring equinox to be that medium amount of rays. All right, moving on. Page 10, basically some of the prior knowledge to work off of was just the fact that if you were to plan a ski vacation in New Zealand, you would actually want to do that in July. The months that you would want to visit the beaches of Argentina would actually be in January and February, okay? The warm-up basically just had you kind of see how the simulation worked. It should have been some type of response close to the Earth revolving around the sun while it rotates itself, and so on and so forth. That's what kind of determines the different seasons. Continuing on that page, what do you notice about Earth's axis as it revolves around the sun? See, it's always tilted in the same direction. That would be that 23.5 degree angle tilt. When is the northern hemisphere tilted towards the sun? The answer would be A, in April and August. And when is the southern hemisphere tilted towards the sun? That would be B, from October to February. All right, moving on to page 11. This is where you had to do a couple multiple steps. You did need to draw in an illustration. The sun would be at its highest point, June 21st, and its highest point on December 21st as well. That would basically mean that on which date was the noon sun higher? That would be June 21st. The Earth's axis, that would be higher in the sky, and then the Earth's axis that would be tilting, it would be lower in the sky. If I were to continue on to page 11, it would be the same thing. We'd change the view of it. You want to make sure that you're looking at the 2D view tab again. This is when we're changing the latitude to -42. If you were to compare and contrast, you would basically say that in the northern hemisphere, the sun would be lower in December and it would be higher in June. In the southern hemisphere would be the opposite, would be flipped. So the sun would be lower around June and higher in December because of that tilt. On Earth, the sun rises in the east and sets in the west. All right, page 12 is going to have you look at solar intensity. The average temperature in Schaumburg in the summer is usually about 85 degrees. The temperature of a typical winter day in Schaumburg would be about 34 degrees. From the graph, if you were to continue and actually set up everything that you needed to for March 21st, you would notice that the solar intensity is the greatest at noon. And the solar intensity at night would drop down to 0. That would be because the way that we are rotating, we would not be in the direct path of receiving the sun's rays or any intensity. Moving on to page 12, a little bit lower, if you were to continually calculate and adjust the days, you would notice that March 21st, the intensity is about 41. June, it's at its highest at 53. In September, it goes to about 41 again. And December 21st, you have it at its lowest point. The dates in the graph show you up on here are sunrise and sunset times, showing you that on June we have the most hours of daylight, and in December we have the least hours of daylight. The longest day of the year would actually be falling on June 21st because of that amount of daylight. The shortest day of the year would be falling on December 21st. The intensity is greater in the summer because the Earth is tilted towards the sun. Therefore, you're going to be getting more of a direct impact of the sun's intensity. Okay, so just make sure you're kind of going through and double checking your gizmo. Make sure you've got everything filled out. Please let me know if you have any questions and email me if you have any concerns. Have a great day, guys.